Hello everyone, my name is Ritik Manghani and today I'll be presenting the successful completion of the first milestone for AetherMart data infrastructure project. The focus of this milestone was to build a robust and secure e-commerce database from the ground up. This presentation will walk you through the entire process from the initial cloud setup and data generation all the way to implementing advanced SQL features and critical role-based security. Our main objective was to establish a secure, reliable, and scalable database foundation for EtherMart. For a fast growing e-commerce platform, a solid data foundation is non-negotiable. It's the bedrock that ensures we can handle high transaction volumes, maintain customer trust through data integrity, and empower our business teams with the accurate real-time data they need for analytics and strategic decision making. This project is split into 5 important steps. First is the environment setup, for which we'll be deploying EC2 instance and installing MariaDB to establish the database environment. Second is data generation. For this, we'll be using a Python script with the Faker library. This will help generate CSV datasets for testing. Schema and ingestion is the third step. Uh, design We'll be designing a relational schema for the database. We'll be loading raw dirty data into MariaDB for further processing. Fourth step is the data cleansing and transformation stage. We'll identify anomalies in the raw data and we'll correct these issues to ensure data integrity. The fifth and the final step is advanced SQL, which will involve creating securities, implementing views, stored procedures, UDFs for better database functionality and reporting capabilities. Uh, this is the project flow chart that we'll be following. Setup and data generation. Setting up AWS EC2 and MariaDB. Generate messy CSVs using Python script. Loading and cleansing data, which is ingestion and cleansing scripts. uh, we'll be using those scripts for ingestion and cleansing. Clean and usable EtherMart DB. Implement views, UDFs, roles. We'll be using advanced SQL and security scripts for that. The final database is ready and secured. That is the end of the milestone. Uh, so the entire infrastructure was built on an Amazon EC2 instance running Ubuntu with MariaDB as a relational database. This cloud-based setup is crucial as it provides the scalability EtherMart will need to handle future growth. To simulate real-world challenges, we developed a Python script using the Faker library. Before that, we'll need to set up the EC2 instance. For this, we'll be using the script provided by Dr. Gamaliel. This is the script that we are using, and this is the Python script that we'll be using to create the Faker sample data. As you can see, we have multiple hundreds of thousands of records in all these tables, which will mean that the CSVs, whatever we are generating, have hundreds of thousands of records. More importantly, I intentionally introduced messy data like multiple date formats, null values for emails, and invalid text and numeric fields like rating. This will create a realistic problem that requires a robust data pipeline to solve. For this project, we adopted an ELT strategy, extract, load, and transform. The data was extracted into CSVs using the Python script, then rapidly loaded into the database. The transformation happened after loading, which is a modern, highly efficient approach that leverages the power of database engine itself to process data at scale. So first we'll be using uh, the schema script. This is the script that we are using to create the schema on MariaDB. Uh, First we'll create a database called AetherMart, and uh, we'll be creating the seven tables that we are using: categories, suppliers, products, customers, orders, order items, and reviews. Uh, Note that all the primary keys over here are in the serial data type, and the foreign keys are in the bigint unsigned data types. This will help us ensure that all the primary keys are in a serial order, in a consecutive order. This will help for indexing. Also, note that the order date over here is in varchar format. This is done to accommodate mixed data formats, mixed date formats for later cleansing. And even for the rating, we are using varchar. Later on, we'll change it to int. Later, we'll be using the data ingestion script for ingesting the data from all these CSVs onto our MariaDB tables. This will be done using the load data local infile command to bulk load the raw CSVs. This is significantly faster than traditional methods. The third step will be the transformation, where we'll be cleaning and standardizing the data after loading. So before data cleansing, the orders column had, I'll quickly show the data cleansing SQL. Over here, as you can see, we are performing the transformation of data for emails. We are updating customers, set email is equal to null, where email was just a blank string. This is done to clean empty emails in the customers table. To handle the date transformation, I added a column called order date clean, and to handle the different date types, I set the order date in a similar fashion. Similarly, for reviews rating, we handled it by adding a new column called rating clean, uh, which is in the int data type, like I just mentioned previously. All the invalid, uh, earlier there were empty strings, invalid text formats, or null data, and now it all just safely sets the value to null. After the data cleansing is done, the orders.orderDate column, which had three different formats making it inconsistent, now has a new clean date column, which was created for order dates, standardizing the format. The reviews.rating column contained a mix of numbers, texts, and nulls. The reviews.rating column now is converted into a clean integer column. Uh, Next, empty email strings in the customers table were left unaddressed. Now they are replaced with with proper null values for accurately querying. Data was unusable for analysis due to these inconsistencies. Now it's much better and we can query it properly. Moving on, with clean data in place, we built powerful features to make analysis easier for our business teams. In this step, we are using the AetherMart database. This is the script that we are following. What we are doing here is that we are creating views for abstraction of the base tables so that personnel with a specific role access can only access the tables that they are granted permissions to. For that, we are first creating the views and then we'll grant the access uh, on depending on the roles. Here we are creating all the views, stored procedures, and UDFs. This script implements several features. We created views like product details to provide simple pre-joined look at our data. We also developed a user-defined function, get customer loyalty, to calculate the customer's loyalty tier on the fly. Finally, we encapsulated complex logic into stored procedures like SP, get customer's order history, which allows one to pull a customer's order history with a simple command. So virtual columns for order items, we saw that. This column automatically calculates the quantity into price per unit for consistency and simplified queries. For simplified product details here, we created a view that had specific product details. It simplifies browsing and enhances usability for users. Customer lifetime value view. Over here, we had pre-calculated summary of each customer's total spending. This view provides insights into customer lifetime value. Customer order history procedure, what we saw, it implements a stored procedure to retrieve all orders for a specific customer. This feature streamlines access to customer order data. Finally, customer loyalty function, like we just discussed, it has the three tiers, new, silver, and gold, to categorize customer loyalty. Moving on, security and access control. To meet the CTO's security requirements, we implemented a robust role-based access control system based on principle of least privilege. For this, we'll be using roles uh, per roles permission SQL that I created. So David Miller, who is the database architect will have a database architect role. Alex Kim, who is the CTO, will have a CTO role. Sarah Chen will have a product manager role, and Maria Rodriguez will have a marketing analytics role. So we grant permissions to these roles. For this, I used generative AI to help me with writing the scripts. For now, I have used the same password for each of the users. We'll just look at the how different users can access different tables in a while. As you can see here, we created specific roles for key personnel like product manager. We then granted each role only the specific permissions needed for the job. The product manager can view sales data but is explicitly denied access to sensitive customer data. So this is the data that we have. So the view product details, view looks like this. It contains all the details related to the product, including the supplier name and price. Similarly, we did that for the customer. And now coming to grant the roles. So over here we are creating a user for Sarah Chen and entering a password. Now when Sarah is only allowed to view product details since she's the product she's the product manager, like we just said, right? So uh, she is able to view the product details view, but when we try to access the customers table when through the role, we are not able to do that because that access is not there. Similarly, when we do it for Maria Rodriguez, she Maria Rodriguez is the marketing analytics uh, person. So she has access to all the customers' data, all the orders data, but no data regarding the product details. So, like we just discussed a while back, principle of least privilege is is being used. This ensures that users only have access to the data necessary for their specific roles. Business specific roles, four roles were created: DB architect role, CTO role, product manager role, and marketing analytics role. The product manager role can view product and sales data but is restricted from accessing the customer personal data. The marketing analytics role can analyze customer and sales data to measure campaign effectiveness. In conclusion, for milestone 1, we have successfully built a powerful and secure database foundation for EtherMart. We have established an efficient data pipeline, transformed messy data into reliable asset, implemented advanced SQL features to accelerate business analysis, and secured the system with granular role-based access controls. This work provides EtherMart with scalable platform ready for future growth. Please do let me know if you have any questions. or need any clarifications. Thank you so much.